Good morning, everyone. I have festivals are over, and you should also focus towards studies because most of the students they are not coming continuously. They are still enjoying their festivals. This much relaxation is not good. Kavya, Kritika, good morning. We are going to talk about drift velocity. Now you need to understand some factors. Last part we have studied about in electricity. We have discussed about most important sections yesterday. We were discussing about yes. Good morning, everyone. So we were discussing about drift velocity. We have not discussed. We were discussing about potential difference and voltmeter. Mahalakshmi, good morning. So this is what we have started for voltmeter and potential difference. These were the two things we have studied, and I was about to ask some questions. Yes, questions based on the content we have discussed. Now, today, what we are going to do is we are going to understand electricity. In electricity sections, what and all we have to study that we are going to discuss. But please come on, everyone, in form. Yes, Mahalakshmi. Yes. So what we are going to do here is we are going to understand some of the most important things in electricity, electric current. So what makes the current to flow in a circuit? The first question is what is making the current to flow in a circuit? This is the first question for me for today. What makes the current flow in a circuit? Okay. Electrons, no, electrons are there, but what makes the current flow in a circuit? Means if somebody will be telling that the current is, thank you for liking the class, what makes the current flow in a circuit means what? If somebody will be asking you, what is the reason behind the current is exactly flowing in the circuit? So what makes the current flow in a circuit? Then you have to say that the potential difference maintained in the circuit will only allow the current to flow in the circuit. Otherwise, it is not possible. Yes, the potential difference. It's the potential difference between the wire. It's the potential difference between the wire when the electron. That's what. That's what. It's the potential difference. Yes. It's the potential difference. You remember this word? It's the potential difference. Okay. Jasmita, good morning, beta. So it's the potential difference between the ends of the wire. Understood? It's the potential difference between the ends of the wire. Sophia, good morning. Yeah, potential difference. It's the potential difference which makes the electric charges to flow in a circuit. That's the most important thing. Which makes the electric charges to flow in a circuit. It is the potential difference. It is the potential difference. We must remember that it is the potential difference. Okay, so if somebody will be asking you what answer we are going to say, it's the potential difference. Potential difference. So it's the potential difference. Good morning, Ashwita. So it's the potential difference across what you call across the wire means across the wire means in the end of the terminals. Sorry, in the end of the wire, one potential difference is generated, and that potential difference allows the current to flow in a circuit. That potential difference allows the current to flow in a circuit. That's the most important thing. So what is the question has been asked is what makes the current to flow in a circuit? The correct answer is it's the potential difference. In one word we can say it is the potential difference which makes between the end of the wire. Potential difference between the end of the wire. Between the ends of the wire. Potential difference between the ends of the wire. That's the answer is the potential difference between the ends of the wire which make the electric charges, which make the electric charges, which makes the electric charges, which makes the electric charges to flow in the circuit. which makes the electric charges to flow in the circuit. That's the most important thing. Yes, Kavya, potential difference between the ends of the wire which makes the electric charges to flow in the circuit. That's the correct answer. Because of this only the conduction of current is there. So this is the most important part. But that means what? We need either a cell or a battery or some conducting devices. Understood or not? We need something which is going to maintain the potential difference. We need something which maintains the potential difference. That's the most important answer. We need something to maintain the potential difference. Okay, computer. We need something to maintain the potential difference. Computer. We need something to maintain the potential difference. That's the most important answer. Okay, so what is actually the electric circuit? The electric current is what? If somebody will be asking you, good morning, Alpha. So here another important point is, if somebody will be asking you this question, how you are going to answer the question. That's the most important thing. Divya, good morning, beta. That's the most important thing. So electric circuit is a flow of electric charges. So now we are going to go towards the next important section. First, to good morning, Sharmila. First, to we have understood. Come on, get ready, please. Now look here, beta. So if somebody will be asking you all these questions, what and all, and how confidently you are going to answer. Flow of electrons in a circuit. Yes, beta. Always people say that the positive charges are going from positive terminal to negative terminal. Because of the flow of positive charges from positive terminal to negative terminal, the current is exactly flown. But actually, what is there is, it's about not the that's the conventional direction. What we are calling it as conventional direction. What it is called as conventional direction. Ashish, good morning, beta. That's the conventional direction. But that's not the truth. The conventional direction is exactly why, because when there was no electrons, we have not discovered electrons at that particular time. What we have done, we were knowing about positive charges and negative charges. So since when we were knowing about positive and negative charges, note down, since we were knowing about positive and negative charges, because of that we have exactly made like, okay, fine, the positive and the negative charges are responsible for the conduction of current, and we were knowing that the current will be moving from a positive terminal towards the negative terminal. That was the conventional direction. Conventional direction means convention. By convention we have done. But actually it's not about the flow of positive charge. It's about the flow of electron which is coming from negative terminal towards positive terminal. It's the flow of electron from negative terminal towards positive terminal. So how the electrons are actually flowing from negative terminal to positive terminal? That is also, yes, from region of lower region current flow. See, exactly region of higher potential to a region of lower potential current is flowing. Region of higher potential towards a region of lower potential, the current is flowing. That's exactly the convention. That's the convention. But we are going to understand in much depth. Okay. So to generate the depth, I'm going to explain some most important factors. So now let's see. Did you understood this one? That means what? First thing, what we learned, potential difference between the ends of the wire, which makes the electric charges to flow in a circuit. Between the ends of the wire, and it is making the electric charges to flow in a circuit. Okay. Now next part. So if somebody will be asking you this question, so now I'm going to go to the next section where we are going to understand drift velocity. We need to understand the things in a much clarity, because till now we did not got clarity. But in your respective group, say everyone to join. This is too much. I can't waste my time. Better switch on this light though. This light. So this is exactly too much. Every morning means what's the festivals are over now. The most important thing is festivals. Thank you, beta. Festivals are over and we cannot waste our time like this. We have 90 days slot ready. Because of that, I can't waste my time for every day calling them, please come, come. Festival, one day holiday taken, given means okay. I took one day holiday means okay. Every time taking holidays and all this, I'm not going to entertain people, those who are having that habit. Okay, now drift velocity. So like first understand what is the meaning of drift velocity. The velocity with which I will push you continuously is the drift velocity. You need to understand that. Okay, so actually what is happening in the circuit and how the drift velocity is generated. So now we need to understand what meaning of drift velocity. First understand, in a conductor, see, in a conductor or a wire, negatively charged particles called electron have random, negatively charged particles called electron have random or zigzag motion as shown in the figure. Can you see the random or the zigzag motion of electrons? Therefore, the net flow of the electrons or net flow of the charges across any cross section of conductor is zero. Understood? So net flow is considered as zero. Net flow of electron or charges in a conductor is, Tarun, good morning. So that is conductor, net flow of the charges is considered as zero. This you please note down, because in book it will not be given. This is because number of electron flowing through the given cross section to the right side is equal to number of electron flowing to the left side of the cross section. So right and left side, whatever number of electrons will be there, the number of electrons will be same, and because of that only the net flow is exactly considered as zero. The net flow is considered as zero. Please kindly note down. So negatively charged particles called electrons have random or zigzag motion. They'll keep on moving here and there. You need to understand this part. Good morning, Anu. So this section is a very important part. I want everybody to listen this very carefully. So what is exactly, so in a conductor or a wire, so if I am taking a conductor or a wire, what will happen? The electrons that is present, so from this electrons or ions, what you can say means the electrons that is present in the outermost orbit of any conducting device. Like simple example, I am giving you copper. Okay, now copper, two electrons are present in the outermost orbit. So these two electrons are not bounded by the nuclear. So because outermost orbit, extra two electrons are there. So these two electrons, it's not like it is not needed. It's like they are not having that much nuclear, what you call, attraction. Understood? So what they are is, these ions are free to move. Got it? So what they are doing is, they are not moving in any regular pattern, they are moving in random zigzag manner. So the conductor, like if you are going to take a copper wire, so in the copper wire, the outermost electrons will always be in some zigzag motion. Understood? So now what is called as cross section. So now, yes, nuclear force is less, you can say also that part. And another important thing is, you will be seeing cross section. So the wire will be always in the shape of a circle. So here the number of electrons this side and number of electrons in the left side and the right side of the wire remains the same. Got it? So here, since the number, the net charges, the net electrons present in the faces will, or the in the cross section remains the same. So that's what they are telling. What they are telling here is the net flow of the electrons or the net flow of charges across any cross section of conductor is zero. Understood? So any conducting device, their net flow is zero. Because of that, they cannot conduct electricity until and unless we are going to apply what? Potential difference. Until and unless we will not be applying potential difference. Potential difference is exactly generating a drift, a push. So you need to understand that the potential difference will be generating a drift or a push. So it's just like we all are standing, we are having zigzag motion in our own area. So but there is nothing which can push us from one part to another part. Understood? So here what we are doing here is, once something will be coming and charging, hey, come on, you have to move in this direction. That means what? We got motivated, we got some energy, or we got some push. So because of that motivation, energy or push, the electron will move from one terminal to another terminal. And that's exactly considered as a drift velocity. So drift velocity, so the electron will be moving in zigzag motion in the outer part, and the net flow will be exactly zero. Remember this part, the net flow is exactly zero. So what Mahalakshmi is telling, that the number of electron present right side is equal to the number of present in the left side. So the force exerted by both the side net, yeah, that's exactly zero. That's exactly zero. So in the face, so face means this face, the faces of the wire, the right and the left side, it is exactly, the net flow is considered as zero. What is the net flow? the net flow is 0. So like in this phase, I'll talk about numbers. If this phase number is 100, that phase number is 100. So they are in their zigzag motion, they are in their potential in their zigzag motion, but they are exactly what? They are not at all having the drift. So now we are going to understand, hence there is no electric current in the conductor. So since the net flow is 0, so there will be no electric current in the conductor. I hope you might have understood. See, electrons are present. See, conductors, the electrons, the outermost orbit, the electrons are there. They are present. They are moving in zigzag manner. They are moving in zigzag pattern. But what problem happened? They are not able to conduct current because their net flow is 0. What is the net flow? Jotam, very late. Jotam, very late. I am expecting you to be very, very last 90 days. Jotam, I want you in my place and I want you to be fully, because you are one of my person who can give me good score in both math and science. Okay, so now look here. So now one most important thing is the cross section net flow becomes 0. So net flow is coming as how much, beta? Net flow is coming as 0. Okay, so once, good morning Gopika, thank you for liking the class. And you need to understand two things. What are the two things we have studied? Come on, say. The electrons will be present, the number of electrons in the phases remains the same, so net flow is 0. Is there any conduction of current? No. The correct answer is, thank you so much. So what is the correct answer? Is there any net flow? The correct answer is 0. Understood? So that means the wire is a conducting wire, but is it applicable? Very good. The wire is a, thank you for liking the class, beta, but the wire is a conducting wire. See, we need to understand that the wire is a conducting wire. So since it is a conducting wire, but will it conduct current? The correct answer is 0. No, it will not conduct current. Thank you so much, beta. But most important is there is no electric current in the conductor. There is no electric current in the conductor. What next? However, when the ends of the conductor are connected across a dry cell, there is a potential difference across the conductor. So that means what, beta? Where it got connected to? A dry cell. Understood? See, there are different type of voltaic cell is there, dry cell is there. So different type of cells are there. So here one cell or a battery will be a combination of cells are called as battery. A combination of cells are called as what, beta? A combination of cells are called as battery. So first to everyone, please remember this part. Yes, beta, in your group, will you post this message? Will you post this message? This is too much. These many students are there and they are not attending the classes. Okay, so that means what? We have learned a very important thing here is what should be generated in the circuit? Potential difference. And to generate a potential difference so that the electrons will have a motion, what we are needing? We are needing cell or a battery. So they help in generation of potential difference. Good morning, Vital. What is Kamals? What is that? So I hope you might have understood. So here, this is exactly the most important thing. So area of cross section, we have understood. Now we are going to Vital. What happened? After so long, I met you because of Deepavali festival and all. Classes were not regular, but since yesterday itself started. So now look here. So there is no electric current in the conductor. No electric current until and unless you are exactly going to connect a circuit. Okay, Krish, good morning. It's too late. Now we are going to so how the electrons, now the electrons move from one end to the another end of the conductor, because what they gained here, they gained a drift. What is the meaning of drift? Drift means a type of push. Drift means a type of push. How this drift is generated? Now let's listen, see this one, how this drift is generated. Let's see how the drift is generated. So we are going to understand how the generation of drift is there. So now I'm talking about one or two resistors are connected in the circuit. Okay, and after that you see this one. This is exactly the battery or the This is exactly the battery. Okay. Now here ammeter connection is there, positive and negative. So now what happened here is the circuit is ready. The circuit is ready. It is relaxation time. Okay, the circuit is ready, and because the circuit is ready, we will be expecting flow of current. So when we will be expecting flow of current, what actually is exactly going to be seen here? So we need to understand two things here. First thing is keep the wire is a conducting wire. Resistors are those which is exactly, so wire is what? Wire is a conducting wire. The conducting wires will have, see, if we want to see the wire, inside the wire how it is looking like, see, the atoms are present, because we know that the conducting devices are made with atoms. Understood or not? So these atoms will have outermost orbit. Come on, these atoms were having what? Outermost orbit. In outermost orbit, the electrons are present there. Understood? Now the electrons are moving in zigzag motion. So here, if we will be seeing in much clarified way, we will be seeing that the electrons are exactly in somewhere random motion. They'll keep on moving like here and there. Understood? So electrons are present and they will be moving in zigzag motion. So there is no continuity, there is no flow in one direction. Okay, so conducting wire, though it is a conducting wire, then too it is not at all conducting current. Got it? But what if it is getting connected to potential difference? So what is happening here is, okay, once the battery is getting connected, now zigzag motion, absolutely better. So once the battery is getting connected, what will happen? A drift is generated, means energy variation is there. So one side positive and one side negative. So once the cell or battery is connected to a circuit, what is happening inside the battery? Inside the battery, chemical reaction starts. Okay, so first we need to understand that inside the battery, what is the starting? Chemical reaction. So once the chemical reaction inside the battery is starting, it will do one very important work. It will exactly create variation. Understood? About positive charges and negative charges. So definitely in this, the positive charge, and in this side is the negative charges, which is associated with electrons. Understood? Now there is a variation. One is higher terminal, one is lower one. So one is exactly positive, one will become negative. So whatever negative electrons will be there, they started pushing the electrons present inside the conducting wire. Understood? Because there is energy variation. One is a positive one is a negative one. So here definitely when in a house or a family or anywhere, one simple example, and higher and lower. Yes, we can say it as higher and lower. But when in a family or anywhere, you will be seeing some type of conflicts are there. What happened? You move in opposite direction. Correct now? So here also the negative charges, that is the electrons, what they will do, they will start moving towards their own side, and the positive one is exactly moving in this own side. Understood? So there is a concept, we can flow with that concept. So what happens? All the electrons will start pushing in one direction. So what they will do? They will generate a push. They will generate a drift. Understood? Yes, they will generate a drift. So you need to understand one more important point. The drift is not a very continuous push. It is like this: push, pull, push, pull, like that. So what will happen? The electrons that is present inside, what they will do is, the electrons that is present inside, now they were having zigzag motion. Once the drift is exactly generated there, all the electrons will align and they will start moving in one random direction. Understood or not? So once all the electrons, because in the circuit all the electrons were moving in zigzag motion, once these electrons started moving, they will align the electrons to move in one particular direction. I hope you might have understood, and that is exactly called as drift work. It is the work of the drift. Understood? The energy which is pushing the electrons, the energy which is pushing the electrons to go from negative terminal towards the positive terminal. Yes, that is exactly called as drift velocity. Drift velocity, what we are using the word here is drift velocity. What word we are using? The word what we are using here is drift velocity. So now let's check this one out. However, when the ends of the conductor are connected to across a cell or battery, potential difference across the terminal is generated. Understood? So now the electrons move from one end to another end, from negative towards Positive. But the motion of these electrons is not in a straight line. Hence, the electron collide with the ions of the conductor while moving from one end to the another. This is the most important point, children. Remember this one. So what is exactly happening inside? The ions means the positive or the negative ions. So here you please remember, now the electron move from one end to another end of the conductor, but the motion of this electron is not straight. Is the motion of the electron straight? The answer is no. The motion of the electron is not straight. So motion of this electron is not in straight line. Hence electrons collide with the ions of the conductor. Electron is colliding with what? Ions of the conductor. Electrons are colliding with what? Ions of the conductor while moving from one end to another end of the conductor. As a result, these collide electron drift from one end to another end with the average speed known as drift velocity. Please note down this one. So yes, ions of the conductors, see look here, ions of the conductors, whatever ions of the conductor, because the electron left na, the electron left. So if I'm sodium, just one simple example, if I am copper, so copper I have given 2 electrons. So once I have given 2 electrons, I will become ion. Okay, Cu2 plus ion. So my electrons are roaming here and there. So I am the ions. So when the electrons will start moving in particular direction, what they will do? They will push me also now, because I am on the way. Are you understanding this? So simple concept is this one. So I am ion. My electron itself will start pushing me. It will start colliding with me at the time if journey is started. Understood? Because where the electrons will go? Electrons will not vanish now. Sorry, atoms will not vanish. The atoms have given the electrons. Now the electrons are exactly, the atom becomes the ion. Atom becomes what? Atom becomes the ions here. Understood? Because they have given the electron, and in due course of motion, this electron who is coming out from the atom, now the atom becomes ion, they will start colliding with the ions itself. Yes, they start colliding with the ions itself. This is the most important thing. See, but the motion of this electron is not in a straight line. This electron collide with the ions of the conductor while moving from one end to another end of the conductor. As a result, these collision electron drift from one end to another end with an average speed known as drift velocity. This is an average speed. This is not the total sum speed. This is the average speed. So the drift velocity of electron in a conductor is very small. So typical value of drift velocity of the electron is 2.22 into 10 to the power minus 4. Remember this, meter per second. It means electron will take time about 2.5 hours to travel 5 meter long conductor. How much time it will take? 2.5 hours to travel 5-meter long conductor. So if 5-meter long conductor is there, yes, Ilaversion, this is too late. You people must join. These are very, very important things I am teaching. So please kindly note down this one. You will not be, as 2.5 hours it is taking to going 5-meter long conductor. 5-meter long conductor. So drifting part is exactly the most important thing. I'm going to draw and explain so that you'll get a picture and you'll get a clarity. Okay, so first note down this one. Everyone note down this one. About drift velocity, everyone note down this one. So the drift velocity of electron in a conductor is very, very small. Typical value of drift velocity of electron in a conductor is about 2.22 into 10 to the power minus 4 meter per second. Yes, 2.22 into 10 to the power minus 4 meter per second. So it means electron will take time about how much hours? 2.5 hours. It is taking how much hours? 2.5 hours. That is traveling how much long? 5-meter long wire. That's very, very slow. Understood? So if it is very, very slow, then how the conducting current is exactly going so fast? If it is so slow, then how it is going so fast? We need to understand that. So please kindly solve this question. Come on, go for it. Try to solve this question. See, electric potential at a point of electric field is this much when charges are flowing. I want everybody to try this question. Please come on, go for it. So here, what is the question given? Electric potential at a point in electric field is 0.5 volt. When charges of 3 coulomb are brought from infinity to that point, calculate the work done. Directly, we know potential is given, and potential is 0.15 volt is given. Now potential given is 0.5 volt. And how much is the charge given? 3 coulomb. So now work done is equal to potential into charge. So directly answer is coming as 1.5 joules. Only multiplication is there. Nothing big work is there. This is the most easiest question. Now one concept I need to explain in a very elaborated way. I want everybody to understand this. Come on, check this one out. I want everybody to understand how drift velocity is working and how it is exactly very, very important. See, understand, this is a conducting wire. Okay, now in this conducting wire atoms are there. So you need to understand one thing. When atoms are there, so these are exactly structure of atoms. Got it? These are what? Structure of atoms. So in this structure of atoms, what happens actually is the outermost orbit electrons are there. Got it? So now what happening here is that these electrons will have zigzag motion. Outermost orbit electrons, the nuclear force is quite weak to hold them. So what these idiots will do? These idiots will move in zigzag motion. So now if they are coming out from atom, so this atom will get converted into ions. Understood? So these atoms are now not atoms, they are getting converted into ions. Why? Because of this criminal electrons. This criminal electron in the outermost orbit will leave and give them an ion feature. Got it? But what happen if this wire is getting connected with terminal like cell or a battery? What will happen? Now this wire. Understood. Now this potential difference is generated. Once the potential difference is generated, what will happen? They will start pushing the electrons. Now these electrons will move and they will push these electrons also to move. But what is the problem here? The ions. So these electrons, at the time this drift will be there, all the electrons, this push will be there, all the electrons in the circuit will start moving. So at the time when it is moving, whom it is colliding? It is colliding with ions. It is colliding with whom? Ions. And when it is colliding with ions, what will happen? Its speed will be reduced because the collision will be there. These electrons which is now moving, they will collide with the ions that is present. How the ions are formed? Because of release of outermost electron. Because of release of outermost electron, the ions are exactly formed. Now at the time when it is going to meet and fight with the ions itself. This will reduce. So see, if I am walking in a what you call empty path, definitely my speed will be more. But if the path is full of people, what will happen? Then my speed will become slow. So drift velocity is average velocity. Drift velocity is average velocity. I hope everybody might have understood. So drift velocity is what? Average velocity. Children, is it clear to all of you? Is it clear to all of you? Come on, say yes, we have understood. Yes, and that is exactly it. Because of the electron will be colliding. Thank you for liking the class and thank you for understanding. Everybody, please kindly start saying yes, understood, yes, understood, yes, understood, yes, understood. So that's the most important thing. Yes, super, super. So we have understood this part. Now we are going to go to the next section. Very good. So now what is that part? Sharmila, yes, join. Okay, very good. So, yes, very good. So now we are going to go for the next section. So this was the most important thing, and yes, beta, this was the missing link. This was the missing link because the current electricity means most of the students, they are having one problem. They think that electricity is something coming from space. It's not from space, it's from electrons. And electrons now, the science is proving that electrons are present everywhere in the universe. Understood? The nanoparticle existence is now proved. The particles, which is exactly the subatomic particle existence, is now proved. Understood? We cannot deny the presence. What cannot be seen from eyes cannot exist is a wrong concept. What cannot be seen from eyes can also exist, and they can exist in a very, very strong way. Its influence can be seen forever. Got it? So that are the some of the concept we are not going to deny. The future generation is you. You people are going to mark a change in the coming science and physics field. Okay, so just make a very, very good impactful examples for everyone. So now look at it up. What I am going to do is, now just see the flow of charges in electric current. Now we will go to the next section. In the next section, what we are going to understand, that lower potential and higher potential. What is the meaning of it? Lower potential and higher potential. Anybody will say current definition is charge by time is exactly current. That's it. Charge by time is exactly current, and study like that. So we are going to say that we are not from that generation where whatever you will say we will trust. Until and unless we will not have our own concept, we will not be accepting the truth. Got it? So we need to get a clarity for the truth also. If it is a truth also, we need to get a clarity. Correct now? So now we are going to understand it. So electric current is defined as continuous flow of electric charges. The continuous flow of what, beta? The continuous rate of flow of electric charges. The continuous rate of flow of electric charges. Come on, go for it. Note down first. So it is defined as continuous rate of flow of electric charges is the definition of electric current. So considering the flow of charges through a conductor, we are going to check the flow of charge here. Come on, see. This is lower potential and this is higher potential. Lower potential is considered as negative. Higher potential is considered as positive. We have done in the circuit itself now, beta. At the time we were drawing the circuit, so negative part and positive part will be there. So can we explain? So if the electron is coming from negative to positive, current will go from positive to negative. That's the conventional direction. Okay, so that means what? The current is going from positive to negative and the electrons are moving from negative to positive. Electron from negative to positive and current from positive to negative. So direction of flow of current is from positive to negative, and direction of flow of charges or electrons, whatever you can say, is exactly from which direction, beta? Negative to positive. So now this is exactly called as area of cross section. Okay, so this area of cross section is there. This is lower potential, negative terminal. This is higher potential, positive terminal. So area of cross section is there. So you can see that the electron is moving in this direction and current is moving in this direction. Higher to lower is current, lower to higher is electron. Understood? Higher to lower. So conventional direction we are talking about. So now we are going to understand current formula is rate of change of charges. Rate of change of charges. Absolutely. Rate of change of charges. That's the most important thing. Rate of change of charges. So here the continuous flow of electric charges will be there. So rate of change is there. Means because of the time the flow will be not unique. It will be exactly changing. So that's why it is considered as rate. With time it can vary. So definitely it is considered as del Q by del T. That is the definition of current itself. Yes, absolutely. So rate of change, because the change is there. Time is changing. Current flow is also changing according to the need. What is the SI unit of current? The SI unit of current is ampere. What is the SI unit of current? Ampere. Come on, go for it. Note down. Now current is a scalar or vector? Current is a scalar or vector? Come on, check. Vector. Ampere. Come on, say. The correct answer is current is scalar. If you change the terminal, the current flow will change. Yes, if you change the potential, means it is exactly going to change. So definitely it is exactly what? It's a scalar quantity. So note down, current is a scalar quantity. Now please note down, current formula is amount of charge by time. Current formula is exactly considered as amount of charge by time. Very good, Jotam. Everyone, please kindly be on the league, be answering the question. You need, if I have any question, ask the question also. Because physics we are going to do in a very, very slow manner. I am not at all in that mood where I can jump with physics and say that chapter is over. I'm not at all in that mood, because chapter over means everything should be pakka reading part must be there. So each section of physics I'm going to explain with much clarity. So till now, did you understood today drift velocity? You understood now? It is the average velocity. And how it is generated, beta? The electrons will push whom? The ions. They will collide. And because of that, the speed will reduce. Understood? So now here, so what is microampere. 1 microampere is equal to m nano micro, like that will be there. Mu ampere, 1 mu ampere, 10 to the power. Understood? So 1 milliampere, 1 microampere, whenever they will be writing, it will be coming as 10 to the power minus 3, and 1 mu ampere is equal to 10 to the power minus 6 ampere. Note down this one. Yes, milli and micro. Now we are going to understand some very important things. This is exactly something which is very, very important for us. So in a metallic conductor, when an atom loses one or more electron, then the atom becomes a positive ion. This we have already discussed. I drew now. What is exactly the atoms can get converted into ion by loss of electrons. By loss of electrons. And when we give, we become positive, because all people say, "Na, you're a very good person, because you have given, donated." So whosoever is donating will always becomes positive. Yes, beta. So loss of electrons. So all the children, I hope you might have, thank you for liking the class. So now listen. So all those children who are exactly giving, so they are definitely considered as what? They're considered as positive, because they have given. So since they have given, they're always considered as positive. Okay, so since they have given, they are considered as positive. So here positive ions are the most important part. So here, so which remains fixed at the place, one place in the conductor. So atoms are fixed. Okay, who is dancing is the electrons. Okay, so the electron detaches from the atom, become free and capable of moving from one part to another part of the conductor. Vishwa, very good beta, thank you so much. Good morning, Vishwa. So the electron detached from an atom becomes free and capable of moving from one part to another part of the conductor. That's the most important thing. After that, the electric circuit in a metallic conductor is due to flow of electron. In a metallic conductor, the electric circuit is due to flow of what, beta? Electron. The electric circuit is due to movement of what? Electron. So this is exactly the most important part. These are the ions, positive ions, and these are the electrons. Can you see a mix match of that? So this is, thank you so much, Peter. So this is exactly that part. So where you can see a metallic conductor is there, where what and all are there? Ions are there and electrons both are there. In that metallic conductor, what and all things are there, beta? Ions and electrons both are present there. In this metallic conductor, what we are expecting here? Ions and electrons both are present. Got it? So now what next? What next? See, this is what already I explained now, that the ions which who is exactly giving the electron, now these ions are exactly doing what? These ions are dancing. These ions are present and electrons are coming and they are exactly pushing it. See, ions, the atoms are fixed. Atoms are fixed. But who is moving? Electrons. Who is colliding with ions? Electrons. Who is the culprit? Who is moving? Electrons. Who is colliding with ions? Electrons. Okay, who is getting pushed? Electrons. And since the electrons are getting pushed, what it is happening? It is colliding with ions. It is colliding with ions. Super, very good class, because all the people in online also, they are answering continuously. Today the class is very live, very nice. Super. So the electric current in the metallic conductor is due to flow of electrons. It is due to flow of electrons. Very good, Vishwa. So now look here. So note, 1 ampere of current is equivalent to 1 coulomb charge. Remember this one. They will ask 1 pair means what? 1 ampere means how much? So that is 1 coulomb charge in 1 second, flowing in the circuit in 1 second. And that's what is the definition of 1 ampere of current. This is what, beta? This is the definition of 1 ampere current. फर्स्ट आप फोकस करो पढ़ने के लिए. 1 एम्पियर ऑफ करंट, ये क्या सवाल था? मुझे लगा कि तुम क्वेश्चन पूछोगे कुछ पढ़ने वाला. सो 1 ampere of current is equivalent to 1 coulomb of charge. 1 ampere of current is equivalent to 1 coulomb of charge. Understood? Passing through conductor in 1 second. In 1 second, how much coulomb of charges are moving? That will become 1 ampere. That will become how much, beta? That will become 1 ampere. Understood? That's the most important thing. Now, conventionally, we define the direction of current in the direction of negative charges. That's the most important thing. And here only everybody will be failing into this part. So now please pay attention here. So conventionally, we define the direction of current in the direction of flow of negative charges. Conventionally, we are doing that only. Okay. So whereas the direction of current is considered opposite to directional of flow of current. So conventionally, this is that, but direction of flow of current is different. I hope you might have understood. Huh? So here, this is the most important part. This is the most important part. I hope everybody must remember this and don't fail into this section, because most of the problems are coming in understanding into this section only. What is the question here is, conventionally, we define the direction of current in the direction of flow of negative charges. Understood? But what we are exactly getting? We are getting opposite of it. What we are getting? We are getting opposite of it. Absolutely correct, everyone. I hope everybody might have understood this one. So what is the content here is, conventionally we define the direction of flow of current is the direction of flow of negative charges. Direction of flow of what, beta? Direction of flow of negative charges. Everybody understood this one? So I'm going to draw it and I'm going to explain this one. Don't worry about it. So the direction of current is considered opposite to the direction of flow of current. Yes. Next, so an instrument called as ammeter is there. So now come on, we are going to meet the hero, ammeter. Okay. So now we are going to meet the hero, ammeter. What exactly the work of ammeter is, we are going to understand. Okay, beta. So a conductor or a wire carrying current is neutral. This is most important thing. Please children note down. A conductor or a wire carrying current is neutral. Okay, that means its net charge will always be zero. हाँ रे बहिष्यत है सो कंडक्टर और लीगल पर्सन है not illegal. So now look here. A conductor or a wire carrying current is neutral. A conductor or a wire carrying current is neutral. Understood? What beta? Because before itself we have learned about it and we have exactly understood that whatever things are there, it has a net zero. Net charge is exactly equal to zero. Here you need to understand the net charge is coming as zero. The net charge is coming how much, beta? Zero. Got it? Why? Because the electrons are in zigzag motion. That work already we have understood. Yes. So net charge is zero. And which hero is needed? The hero which is needed is ammeter to calculate the amount of current flowing in the circuit. So now we are going to understand it in much details. Let's see. See here. So now we are going to draw this and we are going to try and understand this one. So first work is, I just added some resistor here. So this is positive and this is negative. So conventionally what we are exactly claiming? Conventionally we are claiming a very important thing, and that important thing what we are claiming is the flow of electrons is from negative terminals to positive terminal. And beta, what is the flow of current? From positive terminal towards negative terminal. Understood? So this is the most important thing. One is going from positive towards negative, one is coming from negative towards positive. So electron are moving from negative towards positive and current is moving from positive to negative. Current is moving from positive to negative. That's the most important thing. I hope we might have understood. Everybody understood this one. This is exactly the convention. This is the convention. Negative to positive is electron, positive to negative is current. Positive to negative is current and negative to positive is electron. I hope you might have liked it. You understood the concept today. How is the class? Did you learn it or not? Yes. If you will be present, you will be listening very particularly, you will be able to understand everything. Yes, beta, that's the most important thing. Now we will be going to the next section, because section by section we are going to. Yes, Vishwa, thank you so much, beta. Now look here. Now we are going to understand. See, there are three different type of conducting devices. People have a misconception and they are understanding in a different way. But we need to understand that insulators, semiconductors, and conductors. How many different types are there? Insulators, semiconductors, and conductors. Insulators, semiconductors, and conductors are there. What is the meaning of insulator? The one which do not have any free electrons are considered as insulator. What are insulators? The one which do not have any free electrons are considered as insulator. They will not be conducting the current because of lack of free electrons. So they are called as insulator. But beta, the one which is considered as semiconductor, they are between insulator and conductors. So their conducting power is weaker in compared to that of conductors. Understood? So that means what? They do not have free electrons. So rubber is excellent in insulator. Okay. Now next part is conductors. We are going to talk about semiconductor. They will be behaving as insulator. Note down. This is most important part. The semiconductors will behave as insulator at low temperature. At low temperature, they will behave as insulator, but they will behave as conductor at high temperature. This is the most important part. So I hope everybody, yes, semiconductors are alloys, semiconductors, some metals are also, elements are also acting as a semiconductor. Silicon is there, so different is there, different parts are there, but their behavior will change. They'll not be steady. You need to understand that one. They'll not be steady. They can change their behavior. They can change their behavior. They can be conducting, they can be non-conducting, but conductors are always conducting. Conductors are always conducting. Semiconductors can be conducting, semiconductors cannot be conducting. It totally depends upon what? It totally depends upon one important factor, and that is temperature. At lower temperature, they behave as a insulator. At higher temperature, how they behave? They behave as a conductor. So they will conduct electricity at higher temperature. They will not conduct electricity at lower temperature. That's the most important thing. So charge flow or conduction of current, electric current takes place only if free charge carriers are present. Understood? And beta, here next important point is, since proton are bounded and present in the nucleus, so the conduction takes place only due to electron. The conductions are taking place only due to electron. So free charges, so since protons are bounded and present in the nucleus, they cannot do it. So only the conduction will be taking place due to electrons. This is the most important thing you must remember. The conduction is present due to electrons here. So proton are present in the nucleus, so conduction takes place only due to electron. Remember this one. Conduction is taking place due to what? Conduction is taking place due to electrons. Yes, free electrons are the one which is helping in conduction. Children, are you all ready for the next section? Are you people ready for it? Are you people ready for the next part? Come on, say quickly. Yes, super Kavya. So I think the children are very much charged today because of electrons. Yes, because of electrons, you people are very much charged. So, what we have learned here is, however, because we tend to associate the word positive means surplus and negative means deficiency. So, standard level we are always maintaining. So, definitely, this is exactly the controversy of understanding. Okay, so we have to understand this section in that clarity where we are exactly associating the flow of current is positive to negative, and the flow of electron is from negative to positive. Well done, beta. All of you, God bless you. Now look here, electron charges move from positive to negative, surplus. So it is all because of that. Already we have studied. Now we are going to go towards the symbols. So everything we have detailed version we have learned. Now what we are going to do is, very good, beta. Everybody please write down this one. We need to draw the certain symbols. So when we are exactly knowing certain symbols, so these symbols are very important. So what and all symbols are needed when we will be discussing about the circuit? We need to have the study of the symbols. What and all are there? So commonly the diagrams are there. The diagrams are depicting the things. Okay. So because we cannot draw the real picture again and again, so symbolic presentation is needed. Like a cell, one positive terminal and negative. Only single will be there. You see, it is only single. It is coming as plus and minus. Now here beta, next battery or combination where 2 or 3 will be there. last one part is positive terminal, another part is negative terminal. So this is exactly a battery or combination of cells. So battery is nothing but a combination of cells. Thank you for liking the class today. Children are very para level mode micro milli. Yes, that's already done. So that means what beta, a battery or a combination of cells will be there, and in that battery or combination of cells what we have learned. So the cells combining together will be making a battery. Now plug will be exactly drawn as this. This is an open one and this is a closed one. So you remember this one, this is exactly the open one and this is exactly the closed one. Okay. Now plug, key or switch. Now this is exactly you need to understand. Sometimes now they draw like this. Sometimes they draw like this. Don't get confused, children. Sometimes they draw like this, and like this they are drawing. That is also plug only. Understood? So that is also plug. If this one is closed means one dot will be there, and if it will be closed means beta it will fall in one another like this. They will be doing. Okay, this is closed. But if it is like this means it is open. Open means, can you see, open means the distance is more, closed means the distance is less, they are one on the other. Yes, the distance will be lesser and the distance will be more. Yeah, that's super cool, very good. Less distance means closed. Super. So that means less distance, whenever somebody is talking about less distance means it is exactly considered as closed. That was indeed a very good class. So now look here. Junction means what? See, a wire joint or a junction. So it will be connected. Wire joint or a junction will always be conducted. Crossover means it will not be connected. Okay. Crossovers will not be connected. Galvanometer is different. So galvanometer symbol is this one. They are checking induced current. When you are drawing the symbol of galvanometer, please write one thing. They are checking induced current. They are checking what? Induced current. So just write about galvanometer, and for galvanometer, right, they are exactly checking induced current. Induced current, that's different from current. That is induced current. I'll explain about induced current when magnetism I'm going to teach. At that particular time I'm going to explain about induced current. So better right now you are going to only focus for galvanometer. Draw the structure. I will be explaining what is the meaning of induced current. Okay, induced current, if simple way we can understand, like one wire is there, the wire is not having any cell or battery. Understood? So just understand what is the meaning of induced current. So one wire is there. This wire is not at all having any current. Understood? But I fitted a bulb here. Got it? So now what I did here is I took a magnet and I kept moving the magnet to and fro. Continuous. So what will happen? Because we know that. अरे नाम बताओ. अरे ऐसा कुछ नहीं है यार, तुम जो पूछ रहे हो वो सब नहीं है. So now look here, मस्ती मत कर. Now look here. So what is exactly there is, first you need to understand here is कि like one magnet we have taken and not alpha. Alpha है ना name? Alpha hoax. Alpha hoax means that's the name, huh? So now look here. Channel name Alpha Hawks. Oh, I was not knowing. That's cool. So now look here. So magnet will be exactly moving to and fro. Magnet will be moving what? To and fro movement. We will keep allow the magnet to come, go and back movement. For this we are exactly doing. So once stage will come, what will happen? The electrons which is exactly present will start having motion. And because of that, the bulb start glowing. So exactly, you did not connect any battery? No. Without connection of battery, what happened? The current started flowing in the circuit. Why? Because of motion of magnet. Understood? Because of the motion of magnet, current started moving, and because of this only, this is called as, so here galvanometer is there. So what is the work of galvanometer? The work of galvanometer is to precisely check the induced current. Understood? So only galvanometer is used. The work of galvanometer is to check the induced current. Okay, wire crossing without joining. So this is crossover. What it is considered as? Crossover. Okay. Now heater. So when heater will be there, this is exactly the symbol of heater. This is exactly electric bulb. This is the symbol of electric bulb. This is resistor. But this is fixed resistor. This is what? Fixed resistor. It is not at all changing. Its resistance will not change. But this is exactly tapping key is there. This is tapping key. That's what I told you. Now, when it is open means the circuit is open. So there are two different type of resistor. Fixed resistor or variable resistor. Please remember that one. Fixed resistor is this one. Variable resistance can change. Variable resistor resistance can change. Variable resistors are like this. It can either be drawn like this or it can be drawn like this. This is called as what? Understood? This is called as variable resistor. What it is considered as, beta? It is considered as variable resistors. It is considered as what? Variable resistance. Rheostat also we can say. Rheostat. Understood? Rheostat. Yes, rheostat. We can say variable resistors as rheostat because resistance can be changed. Fixed resistors, this is fixed resistor. Fixed resistors resistance cannot be changed. That is the most important thing. Fixed resistors resistance cannot be changed. Fixed resistors resistance cannot be changed, but variable resistors resistance can be changed. How was the class today, children? Okay, it's time. How was the class today? I hope you might have liked the class. Is it okay? The explanation was good. Was it okay? Thank you for liking the class. Thank you for attending the class so sincerely. Fine. So tomorrow also maths class will be there. Tomorrow also science class will be there. Because beta, what is my concept here is now we are going to go more classes. I'm going to align for class 10th and 12th because yeah, 10th and 12th more classes will be there. Thank you so much, beta. Bless you all. Enjoy your day ahead. Yes, social science. That is social science class, huh? That's not social science class. That's my science class. Fine. Bye everyone. Have a nice day. Thank you for liking the class.